Method 2, you can also algebraically manipulate the equation, and we can work with it in this form as well. So I use the exact same examples as example 4, so you can see we're going to get the same answers, just a different method. So to do this one, you have to actually remember a new form. You would take the first coefficient divided by the the constant term in the denominator, and you would multiply them. So 4 times -2 equals -8. Now I don't necessarily write this out separately, but I'm going to just on this one so you know where this number comes from. So then what we're going to do is I'm going to put -8. I'm going to space out 4x and -5. I'm going to put a -8 in there. I can't just randomly put -8 in there and call this the same equation. So I have to balance it out and also say +8. So really that equals 0. So I'm going to put that -5 there. So this is still equivalent in the numerator. Okay, I'm not touching that denominator. But what this does is it allows me to group the first two terms always and factor. So I can factor out a 4. And this gives me x minus 2. 8 minus 5 is going to be +3. And this is all over my x minus 2 still. And when I do that, every single time, I'm going to have what's left in brackets here the same as my denominator. And I'm going to separate this. I'm going to write the first term over the denominator on its own. And I'm going to write 3 over the denominator on its own. We don't really usually undo addition, but that's really what's happened. So sometimes it's easier to look back at what we did here. If I said to add this, you would get a common denominator, which we would have already, and you would just combine the numerator. So you would take this first term plus 3. So the reason we separate it is that's going to allow us to cancel that out. And now you're left with 4 plus 3 over x minus 2, which we will rearrange and write like this.